Hello everyone, welcome in SIPO Academy, Learning for Growth. In this video, we are going to cover or we are going to solve some examples on special types of square matrices. Basically, we are going to focus on Hermitian matrix. Let us solve one example of Hermitian matrix. Question is, express the Hermitian matrix A as P plus IQ. It implies that the given matrix is Hermitian matrix. So here the diagonal elements, all diagonal elements are real numbers, and this A12, which is in first row and second column, is the conjugate of A21. So basically the given matrix is a Hermitian matrix. Now we have to express this given matrix A as sum of P plus IQ, where the matrix P is a real symmetric matrix, means it satisfies the condition P dash equal to P, and the second matrix Q satisfies the condition Q dash equal to minus Q. It implies that Q is real skew symmetric. Okay, now let us calculate or let us design P and Q. So for that we require conjugate of A. So I'm going to write here conjugate of A. We can write conjugate of A by taking conjugate of each and every element of A. So here A11 is 2, its conjugate is also 2. 1 plus I, its conjugate is 1 minus I, its conjugate is plus I. Conjugate of 1 minus I is 1 plus I. Conjugate of 0 is 0. Conjugate of minus 3 minus I is minus 3 plus I. Conjugate of I is minus I. Conjugate of minus 3 plus I is minus 3 minus I. Conjugate of negative 1 is negative 1. This is conjugate of it. Now I am going to design a matrix P such that P is equal to half of A plus conjugate of it. Okay, this is my P. So I'm going to write here 1 by 2 times P and conjugate, sorry, A and conjugate of A. I'm adding corresponding elements of A and conjugate of A. So here 2 and 2, which is 4. Then addition of 1 plus I and 1 minus I is here 2. Addition of minus I and plus I is here 0. Addition of this 1 plus I and 1 minus I is 2. Next element is 0. Next is minus 6. Addition of plus I minus I is 0. Addition of this is minus 3 plus I minus 3 minus I is minus 6, and addition of minus 1 minus 1 is minus 2. If you divide each element of this matrix P by 2, we get 2 1 0, then 1 0 minus 3, and 0 minus 3, and minus 1. So this is a matrix P. You can check here, all diagonal elements are real numbers, and this A12, which is in first row second column, is equal to A21. This is true for all remaining pairs. So this implies that your matrix P is real symmetric matrix, which satisfies the condition that P dash equal to P. Now we have to write here Q, matrix Q. I'm going to design a matrix Q as 1 by 2I and A minus conjugate of A. If you write such a matrix, which satisfies definitely which satisfies the definition of real symmetric matrix. So I'm going to write here Q as 1 by 2i, and I'm going to subtract all the elements of A conjugate from A. So diagonal element is 0. Then the next element is I'm going to subtract it. So this will be plus 2i minus I, and minus I, which is minus 2i. Then this element is minus 2i. This element is 0. You can subtract corresponding element. So in this way you will get here minus 2i. Similarly, this will be plus 2i, this will be plus 2i, and this will be 0. If you divide each element of Q by 1 by 2i, so Q becomes 0. Then this will be 1 minus 1. This will be minus 1, 0, minus 1. This will be plus 1, and 0. You can see this matrix satisfies the condition. This matrix satisfies the condition that all diagonal elements are 0, and this A12 must be equal to negative of A21, and this is the definition of a real symmetric matrix. So here Q dash equal to minus Q. Hence we can say that the matrices which we have designed P and Q, that P is a real symmetric and Q is a real skew symmetric. And one more very important thing, that P plus IQ is equal to A. You can check P is half. You can see A plus this conjugate of A plus I times 1 by 2I, and A minus conjugate of A. If you open the bracket, this I gets cancelled, and this half A plus half A is equal to full A. Means that P plus IQ, this combination is unique. Thank you for everything.